What is a care engine?
Engine bar there.
Yeah, it's an engine that has an E in there. It's a car that has an E attached to it.
Oh, is it one of those?
It's an executive car.
Oh.
Yeah.
Like a,
You see, yeah, that's why I don't write my own textbooks, you see. I'm sorry, this thing is just doing its own thing.
you can do like the freeze thingy or whatever.
No, it's not working.
So calculus for ants.
Oh, there we go. So the car it has this force and it's exerting on the engine. So what does it work? If you take the force and integrate it from
0, 1.
0, 1. And then now it's just a simple calculus one problem, right? So you just say multiply this out and then integrate it.
Dr. J, shouldn't there be 800x?
Or 800, yeah. What's the antiderivative of 800x?
800. Or
400x squared minus,
800 over 3x.
and you can value that at 1 and 400 like that. 400 minus.
Do that already.
Now, the question is how did the physics or the mechanical engineer determine that this was a force? Now, there are some forces that you know you should know how to determine as exchanges. That is a spring. Anybody know how spring on it, the force on a spring changes?
Like a exponential, some form of exponential function or square root function.
How does the force on a spring change? Well, you have a spring, okay? You stretch the spring. The more you stretch it, the more you stretch the spring and hold it. So you take the spring and hold it here. You know you have to apply a force. If you stretch it even more and hold it, you have to apply a bigger force. So a spring force is proportional to how much you stretch it. It's proportional to how much you stretch it. The more you stretch it,
More force.
the more force you need to hold it. And who has had college algebra? How do I make this an equation? I put a constant of proportionality. Huh? Huh? You want to put a negative there, then your K must should be positive. Okay. Why you do it like that?
It expands the. I'll have to use some root spring.
Well, it has to do with forces. If you apply a force down, and this is positive x, it wants to accelerate up. So that's why the force is negative. But that's if your K is positive. Okay. That is to say, if this is x, so stretch the spring, give x. You stretch it 5 meters. But you have to hold it there because it wants to accelerate up in the opposite direction. This is positive x, and it wants to accelerate up. The same if you compress it. If you compress it, you take a spring and you push it up. You are not pushing it in the negative x direction. It wants to accelerate in the positive direction, wants to bounce back out. Now, what is this K here? What is that got to do with it?
And the strength of the spring.
It's the spring. Now, you take your spring in your old watches before your time. The old watches, they had springs in them. You try to stretch that. Anybody know of a much stronger spring than that? The shock absorbers in your car. You try to stretch that half a meter. And you'll realize how much of force you need. This is the constant of proportionality. I'm sorry?
I started this recently.
You try to stretch your shock absorbers.
You have to have spring compression.
Yeah, just possible.
So, you have to determine this constant. How do you determine this constant? You will determine by calibration.
I try to get the cars like receivers.
That is to say, you will take your spring and you say, well, now